Some examples on using both laws now. So PV equals MRT and P1V1 over T1 is P2V2 over T2. There will be a sheet somewhere with these questions on, so these are the workings out. Number 1, P1 is 2.5, V1 is 0.2, and T1 is 20. We might have to convert that soon to Kelvin. We're increasing the volume. Oh, that's cool. We're keeping the temperature the same. So if we increase the volume, what happens to the pressure? So we can use that formula. Obviously T1 and T2 are the same, so we can get rid of that and just have this. We're going to find P2. So I put the numbers in there. Look, P1 is 2.5, V1 is 0.2, V2 is 0.5, so 2.5, probably 2.5 times 10 to the 6 times 0.2 gives me that, and then so therefore, look, that means therefore, and then I'll leave the P2 there and bring this 0.5 down, so divide this by 0.5 and that will give me P2. You can leave it like that, or you can put ENG, right, 1 megapascal or 1 times 10 to the 6 Pascal. So if we keep the temperature the same, we decrease the pressure, we increase the volume, pressure goes down. Because you're making it bigger now. So number 1, nice and easy. Number 2, we've got T1, P1 and V1. P2 we're going up, we're keeping the volume constant, and we need to work out what happens to T2. And probably work out the mass as well. So I'm going to convert the temperature into Kelvin by adding 273. V is constant, so we can get rid of that. So we've got this. I need to find T2. So I'll rearrange this now. I'll bring the T2 up to there. Bring the T2 up to there, look. And then I'll bring the T1 up. So bring it up to there, long way around. And then we need to find T2, so I'll bring the P1 down to there, which gives me that formula to find T2, P2, T1 over P1. So I know P2, it's 900 kilo, I know T1, it's 293, and I know P1 is 400 kilo. So when you calculate, do that, 900, 3 times by 293 equals that, divided by 400 to 3, is it? Yep. 659 and a bit. So the temperature has gone from 293 to 659. So it's gone up in temperature. So it's gone down in pressure, but up in temperature. The mass, so we can use this formula to work out the mass. And this one, because we know, so we know this is the numbers before, and this is the numbers after. So, because we've got a value for T1, P1, and V1, and we've got values for T2 now, and P2 and V1. So, the mass will be the same regardless, as long as you use that formula, and you either use these numbers, or you use these numbers. Now, I'd be inclined to use these numbers, because we've been given these, and we know they're correct. If you use these numbers, you've got to be confident that T2 is correct. Because if T2 is incorrect, then the rest is going to be incorrect. Now, in this case, T2 is correct, but I could have worked it out incorrectly, which means that my mass would be incorrect, because I'm using this one, which I haven't been given. I'll do both ways to show you. So, there we are. Because we have values for PV and T for before and after, we can either calculate mass before or mass after. going to be the same because it's got to be the same. So before the temperature rise, now these values I'm confident because we've been given them. There's the formula. Rearrange for M, just bring down the RT. There's P, 400. There's V, 1. R is 287 and temperature is 293. So we'll do this. 400 divided by 287 times by 293. Close that, come up. 4.7576, there we are. That's the mass of the gas. Now I'll just use this side because you can use it to check. If you wanted to check that this T2 is correct, and if you use it to find the mass and you get the same answer, then you can be confident in that this is correct. So same formula. So the pressure now after is 900. The volume is the same because it's constant. R is going to be the same and the temperature is going to be 659. So put that in. Equals that divided by 287 times by 659. Close. So yes, there we are. 76. That's the mass. So obviously that temperature is correct. That's the mass of gas. It's going to be the same before and after. Make change in pressure and expand a bit, but the mass will remain the same. So number 3, V1, we've got P1 and we've got T1 into Kelvin. Look, the pressure's going up and the temperature's going up. So they're both changing. What happens to V? We need to find V, we need to find mass. So because they're both changing, there's nothing constant, we'll use this. Got to find V2, so I'll rearrange for V2. I'll bring the T2 up to there. There he is. And then I'll bring the P2 down to here. There he is. So V2 now is going to be that. P1 V1 over T1 is T1 over P2. Now R to D2. So P1 is 100. V1 is, no, put 1, 2. Temperature is 363. Just be careful you don't do like I did. Look. T1 is 293 and P2 is 700. So this will give us what happens to the volume. In your calculator, 103 times by 0.12 times by 363, close that, or divided by 293 times by, close that, overcome the brackets, hopefully 0.02124. So the volume has gone down. So we increase the pressure, increase the temperature, and the volume has come down to that. Now I've got to find the mass. So either before or after. Obviously these are values we know, and these are the values we know most of them, but we don't know this because we've worked it out. So if it's wrong, the mass will be wrong, but I'll use it as a way to check. So PV equals MRT. I'm going to use the after ones just to make sure, because if the mass comes out and it's the same as the mass down here, then I know that that's correct. So PV MRT, rearrange that like we did up there. So PVRT is the pressure, 700. V is what we've worked out. If this V was incorrect, so would the mass, but I'm quite confident that this is correct because I've checked. 287 is the constant, and the temperature is 363. Calculator, 700 times by 0.02124, 0.0224, close, down here, open this, 287 times by 363, close that, come to the end, do that, 0.1427 kilograms. So now I'll do it with the numbers that I know, just to see if we get the same answer. Same formula, just we'll use the values now for before. So P before is 100, volume is 0.12, and temperature is 293. So again, put that in, 100, 3, close brackets, times by 0.12, close, times by 287, 293, close that, come there, press equals, hopefully 0.412. Yeah. So I'm confident that 0.02124 is the correct volume because the masses are the same. I mean, you could make a mistake, I suppose, with that, but adding 20 to 273 shouldn't cause you much of a problem. Same there, look, so. But I would always use the numbers, if you can, the numbers that you've been given, because then there's less likelihood you're going to make a mistake. Number 4, last one, don't all cheer at once. V1, T1 into Kelvin and P1. P2 is the same, so they're constant, look, so we're going to ignore the P's in a bit. We're going up, we're doubling it. What happens to the temperature when we double the volume? And there's my R value. So we need to find T2, we need to find the mass. So here's my formula. Obviously P's are constant, so we can get rid of the P's. Don't like P's, don't like P's. I like cheesy peas, I don't like peas. V1, T1, V2, T2. Now we need to find T2, so I'm going to rearrange this formula. So first of all, I'll bring the T2 up, bring him up, there he is. And then I'm going to bring this T1 up to here, up to there, look, from there to there. And then I'm going to bring, to find T2, I'm going to bring V1 down to here. Thank you very much. So V2 we know is 0.2. We know T1 is here, 293, and we know V1 is 0.1. Put that in your calculator. 0.2 times by 293 equals that, divided by 0.1586 Kelvin. Thank you very much. So if we double the volume and keep the pressure the same, the temperature goes 586, which is an increase. Next thing, find the mass. So PV equals MRT. I'll use these values because I know them. So P is 300, V is 0.1. We know the R value is 287 and T is 293. You could use these numbers and then use that temperature there. So that should be correct. Well, it is correct. So you should get the same number if you go using these values. PV, MRT, P over V over RT. There's the values. 300 times by, shouldn't have to do that really. There we are. Divide that by 287 times by 293, close the bracket, press equals 0.357 kilograms. That's the mass of the gas, correct? Da iawn. That means very good in Welsh if you're from a different country. So, da iawn. So questions on gas laws, the two gas laws, which you'll come across in your assignment. So, bit of practice. Any problems, let me know, and over and out.